How's everybody doing out there? I know chai means tea, but here it means something different. Hey T-Perm, I'm glad you're doing great. Yeah, I know. Here, when people say chai, they mean sort of like a milk-infused tea that's really spicy. So, usually with cinnamon and cloves, and mine actually has ginger pretty commonly. A really strong ginger tea, but milk infused. Since I'm on my own today, I put on the cans so I could listen to music and I don't have to hear the SEM go brr 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 the whole time. But you guys still do. Sorry. Mallory didn't get fired. She, of course, went home for the holidays. And I'm here. So, today I wanted to do some actual research. A lot of times on the stream we're kind of just looking at things for funsies. But I also need to get work done every once in a while. So thought I would try to do a little bit of work today as well as have some fun. So we're looking at some samples that my friend Itzi collected for me, and primarily looking for some very specific diatoms belonging to the genus Afrocymbella. And as a result, I'll probably be kind of 50-50 on paying attention to chat as much as I normally would, or somebody would, in the channel. But it's not because we don't care. It's because it's hard to run the scanning electron microscope and at the same time keep up with what everybody's saying. So if I miss something that you feel is important, you can always just tag me and or repeat it. It's fine. I'll just sort of be bouncing back and forth between what I'm doing and the chat. So right now I'm just trying to get the focus clean. And then I like to do a little bit of work on the stigmation as well. Well, sometimes work is overrated, but sometimes I like to do work. Hey, Karthik, I didn't see you there. Got a fellow diatomist in the channel. Karthik's a really well-known diatom taxonomist from India, and worked with my friend Pat Koselik for a while. I think before returning to his home country. It still works with Pat quite a bit, but it's nice to see you here. I hope you're doing well. I know COVID's been pretty rough everywhere, but kind of ravaged parts of India for a while there. I don't know how things are now. Early on in the pandemic, I was doing some sort of social hours with my fellow scientists, and Karthik would come to those. It was really nice. This week, later this week, I think on the 21st, that must be Monday, we're having a little diatomists get together to do social stuff as well. So it'll be nice to see everybody and hang out a little bit with my nerdy diatom friends who, you know, just haven't seen each other for a long time. I need to find something before I get started too far here where I can kind of check the stigmation. And I like to have something with a bunch of little holes, which most diatoms do, but little tiny holes would be helpful, so I can sort of focus in on it. This has got a little too much clay. Everything we're looking at here is a diatom. As I mentioned, these were collected from Lake Tanganyika, so much of what you're seeing is probably species that are really only common in Africa, East Africa for the most part. There's a lot of endemic species. Some of the things are probably ones that everybody might recognize from globally, but there's also some things that are pretty uncommon anywhere else or exclusively occur in Africa and aren't found anywhere else. Interesting also, there's some diatoms that don't occur in Africa, which is kind of cool. They occur in other places but haven't shown up in Africa. Wait, this is an interesting thing. Some little Gomphinitzia, but these structures are really interesting. So this is Stigma. These little slit-shaped things right here are areolae. They line up to make striae. And this big opening here is the raphe of the diatom. So diatoms are a type of algae. They live in aquatic environments or subaquatic environments. Pretty much anywhere there's moisture and a little bit of nutrients. And this is their skeleton. The cell wall of the algae is made out of silica, and these three little sets of isolated stigma or isolated puncti are really kind of interesting. So at the end of these slit-shaped ones, there's two sets on each. They don't occur at the ends of any of the other. Only in the central area. They don't occur at the ends of any of the other rows of striae. And so there's the stigma, so we know it's not a stigma. So really kind of interesting little isolated puncti, round instead of slit-shaped. And I don't know that I've ever seen that before. I've seen a couple like on the outside edges or just one at the end of the central striae. I don't know that a lot of this stuff has been looked at closely in the scanning electron microscope before, other than by me. Just kind of playing with the stigmation a little. I don't know that I made it any better right there. It doesn't look terrible. So one of the things with the scanning electron microscope is, of course, you can see the scan as it goes across. That's that line that's right there, coming around. And if it's going fairly fast, the image doesn't have great quality to it. I can always slow it down a little, but then it takes a lot longer to draw the actual image. So I'll give you an example of that. I'll just slow it down right here. You can really see the difference that it makes by going from like a 4 to a 7 with respect to both the scanning speed and the resolution of the image. But if I were waiting for this to redraw on every scene, it would get really tedious. You jumped in when you saw the name Afrocymbella. Well, you know, it's nice to see you here. Why don't I use text to speech? Well, I could do that, I suppose. I think it would be kind of noisy, and there's a lot of sort of chat that goes on. Yeah, and then could potentially be people popping in and spamming, but let's see. Is that the silica surface? Yeah, everything you're seeing on the actual diatom is made of silica. That you can see here, because these diatoms have been processed. So they were treated with nitric acid, and then that got rid of all the organic material. And then that little bit that was left is basically just silica. And so anything that's made out of silica will sort of be still present in the sample. And then typically what we utilize to connect it to the stub that the scanning electron microscope uses is we just dry it onto the cover, or a cover slip, or directly onto the stubs in this case. And then I put those things into a sputter coder, which then coats them with gold plating. And the reason that we would need to coat them with gold is that silica is a bad conductor for electricity. And what that means is when the electron beam comes down and hits the diatom, the electrons will sort of stay where they are. And on the edges of things, on the corners of things, they start to accumulate because they don't flow over the surface very well. And, you know, the stub is actually grounded, so things will hit the diatoms and other things, and the electrons will basically get grounded and roll into the machine. But on the edges of things, they'll basically build up a charge. And because the picture is generated by sort of detecting how many electrons are coming off of an area, those areas will look really bright. And for any pictures that we might be trying to take, they'll overwhelm the rest of the image, and so we'll end up with these really bright spots associated with it. So you have to coat it in some type of metal, and in our case we use gold. Gold has the highest conduction for electricity, you know, out of the metals that are easily utilized. So we just put it in sort of a plasma state, and then we can put the sample in there in a little vacuum bell chamber, and it deposits on the surface of it, and it allows us to get nice clean images as long as our samples are clean in the scanning electron microscope. The sample's got a little bit of clay in it, and the samples are coated a little bit, so we're not seeing all of the detail we might like to see. This is an internal view of a gomphinimoid. And normally we'd be able to see some really pretty components to it, like the internal view of the raphy and associated elements, but we can't really there. So if I zoom out to really wide view, you can get a sense of how small the diatoms really are. The stubs that you're looking at that are in the chamber something like 12 millimeters across, but our field of view right now is just about 1 millimeter. So if I can put it at 1 millimeter. So the entire field of view that you're looking at right here in both directions is 1 millimeter. So you'll recognize that as the smallest mark on a ruler that has metric on it. And in that smallest mark, basically, we can see all of these diatoms. There's also a sponge spicule here. So as I mentioned, there's other things that are silica that sometimes will show up in our samples. And sponge spicules are one of the things. We might also come across things like phytoliths and occasionally some other components that are just volcanic ash or other materials that might be present. So one of the sort of challenges of working in an SEM is that if I zoom out so that you can kind of see the entire field of view, a lot of times we're, like other things on a microscope, we're hunting for, through a sort of matrix of very large number of things, looking for something in particular, and everything is very small. So we'll catch you later. Sherlock, thanks for stopping in. Yeah. Pasta says I had a microscopy class where we were looking at plant embryos and used osmium tetroxide for simplicity. Yeah, I don't like really using any of the really nasty chemicals. But the SEM is definitely the best thing to look at. And then Anakin Luke is here. Anakin, I did get Sylvia to post some pictures for you. I think they're in the About section underneath us here. And I didn't draw a picture of the SEM, but I don't know about getting an emote of the actual SEM. I guess I could do something like that, but right now my emotes are all filled up, so I'm kind of limited. You feel cheated? By what? Alright, let me look around a little and see if I can find us some Afrocymbella. This is my sort of mission for the day. The sample's got a lot of clay. Maybe I'll move back to the first one and see if it's any better. So it looks a little cleaner. There's slight differences in the height of the two samples, and so when I jump from one to the next, I sometimes have to change the focus height a little bit. So the characteristics that distinguish Afrocymbella from the rest of these diatoms is, first, they're cymbelloid, so they're shaped kind of like this, but they're asymmetric. So rather than being like a perfect loaf of bread or symbol or whatever, they actually have one side that's a little bit longer and skinnier, and the other side that's a little sort of fatter and wider. So they're pretty easy for me to detect, but sometimes people don't see that detail as quickly as somebody who's used to looking at things that are symmetrical might. This here's a rather well-behaved Navicular internal view, so it's kind of laying on its back. And here's another one of these Gomphinitzia, a different type. This is Ensynema, another Ensynema over here. So as we just sort of scroll around in this crazy landscape, One of the things that I'm looking for in particular is in this sample in the light microscope, I found some Afrocymbella Ungurai, which is a described species of Afrocymbella. And we're working on describing some species of Afrocymbella, and I would really like to have an SEM version of it to compare our results against. And since the primary difference in most Afrocymbella is actually just their shape, their outline, and their size, I probably could do without the SEM image, but I feel like I'd really like to have it. It's an internal view of a Stephanodiscus. It gives me a chance to really work on my focus, because they have a lot of stuff with a bunch of detail on them. Like this is a strutted process that we're seeing right here. It's got 2 satellite pores. You see it's wobbling a little bit, and I want to see if I can fix the wobble. The controls that I'm working on right now just sort of modify how good the picture quality can be. So if I can get the whatever's in focus to basically sit in place instead of moving around. So it's focusing sort of up and down on the surface, and what it's trying to check is how well the beam stays on the target that you're aiming for. And when it's out of alignment, the beam is wobbling, what happens is the image will move around, and when it's not, it will just sit where it is. It'll come in and out of focus, but it won't look like it's going up and down or left and right. And I think I've more or less got it. And that should improve the image quality. And then, of course, we're still not really moving at the best speed for image resolution. But now I'd like to play a little bit with the stigmation and see if I can improve the quality. Stigmation can be modified sort of like at the doctor's office and they're checking my eyes. It's just better and worse, or like a typical focus knob, except for I'm not actually changing the focus at all. I'm sort of improving the focus. In stigmation, what happens is in your eye, in stigmation, what happens is that the lens is focusing the beam in the wrong place. It's not perfectly aimed onto your retina. And so when people have astigmation as an eye problem at the doctor, typically what they do is get glasses that will move the focus of the lens into the right place. And even though we're not using light, a lot of the same components exist in the scanning electron microscope. And when it's really well done, these little guys down here, the domed cribra on the inside of the Stephanodiscus, will actually look like little salt and pepper shaker heads. And it's not quite there. I mean, they're not terrible. You can see it a little bit in here, but I still feel like I could fix it a bit. I may also need to wait until the SEM gets a little bit more warmed up. We were zoomed in really, really far, so... Are there any really cool, unique Afrocymbella traits? Yeah, I will get to those. So I'll come back to that, Pizza. Has anybody ever made a game that uses SEM-like mechanics? I don't know. I don't know anything about that. Maybe. Is it possible to examine plant resins with an electron microscope? I mean, I'm sure you could do it. Part of the problem is that a scanning electron microscope just basically looks at the surface rather than other components. So if you're looking at it chemically, you could look at the elemental composition on a scanning electron microscope. But the resins are, I guess it depends on how small they are and what kind they are. Pizza seems like they're on top of it. And little Chook is here. Hi, little Chook. And also Comrade Bubbles. So I'm going to stop for a second and give some shout outs to little Chook. And you should definitely watch little Chook. She's a fantastic artist. And has been missing because she just recently moved into a new home. And... Comrade Bubbles, who I've been watching a little bit, she checked us out on Wednesday and brought along pasta with pizza to the channel. I'll give a little shout out to Comrade Bubbles. Earlier today she was playing a video game. I watched her play a little chess video game where she froze to death. And let's see. All of the details about me that are publicly available, you could look at the About section and catch. My name is actually associated with my Twitter account. I'm a professor, so let's see. I'm going to talk a little bit about, let's see, there was a question about what's special about Afrocymbella and how could we tell it. So one thing that's kind of special about Afrocymbella is that is only found in Africa, like nowhere else, and actually only found in a few lakes in Africa. Some of the really important and interesting characteristics about Afrocymbella is that, so this little structure is called a stigma, and in Afrocymbella, the stigma on the outside looks like a simple open circle like this, and on the inside it looks basically like a little slit. And its positioning is kind of unique as well. So the rest of the things that we might call symbelloids have the stigma on, I don't know if I actually have any true Symbella in the sample. I guess I could try to look for some. But for them, the stigma is on the ventral side, the sort of belly side of the diatom. But for Gomphinitzia, and also for Afrocymbella, it's always on the dorsal side. And for Diatoms, that's kind of important because the stigma doesn't move around very well. It's kind of a stable structure, and it actually suggests that while Afrocymbella looks like a Symbella, it's actually more closely related to Gomphinitzia. And so it has an interesting shape for a Gomphinitzia. It's asymmetric in two directions, and so actually that's why it got moved into its own genus. But for an expert, once you sort of see an Afrocymbella and you know what the features are that you're looking for, it's hard to mistake it for anything else, because they typically look like a Symbella that's asymmetric, and then its stigma's in the wrong place. So, if we're scooting around our sample looking for Afrocymbella, those are the characteristics that would help us identify it. One of the things that really makes it kind of challenging is there's sort of a gradient between Gomphinitzia and Afrocymbella, and so there are some Gomphinitzia that have characteristics that are pretty similar to Afrocymbella's characteristics, and they just have like a very subtle asymmetry to them, so it's sometimes challenging to pick them out. But I think this is a good example of one right here. So we can't see the inside of the valve, but we can see that the shape of this diatom, also we're missing part of it. So Gomphinitzia are asymmetric in this direction along the axis. So they'll have like a fat end and a skinny end, for example. And Symbella tend to be more asymmetric along this axis and symmetrical along this axis. So transapically they're asymmetric. And so like a dolphin or a whale, they have a back and a belly, and so it's sort of a symboloid shape, even though that's not a Symbella, that's an Ensinema. So we would not mistake this easily for something like a Gomphinitzia, but you might mistake it for Symbella, except there's a stigma, and it's, as I mentioned, on the dorsal side, not the ventral side. So that's a good clue for us that this is actually Afrocymbella. And even though we can't see this end of the diatom because it's covered by some junk, we know that it's probably asymmetric in this direction because it's an Afrocymbella. And also, if we looked carefully at the valve end down here, it's deflected the wrong direction. So it's deflected in the direction, if this were a Symbella, it would be deflected in the opposite direction. It would be smiling. So the Afrocymbella have a sort of shape on the raphy end that's a little bit more like Ensinema. And this is the head pole of our Afrocymbella. And the foot pole is covered up. And the foot pole is usually slightly skinnier. So if I were to measure across right here, for example, and then measure across right here, this end would be skinnier than this end. Again, sometimes it's very subtle, and some of the species that we're working on describing are actually nearly symmetrical with respect to both length and the width of the diatom. So is Afrocymbella photosynthetic? Pizza asked. And of course they're an algae, so all algae are photosynthetic. So it's definitely photosynthetic. All the diatoms that we're looking at here are photosynthetic. Oh, for pottery. That's cool. Why do they only have one stigma? Well, that's actually a good question. I have a number of diatoms that actually have more than one stigma that are in the Gomphinitzia group that I published a paper about. I think it was earlier this year, or really close to the end of last year. And we talk about the multi-stigmate diatoms that belong in the genus Gomphinitzia. I haven't seen any Afrocymbella with more than one stigma on the outside. On the inside, their stigmoids sometimes will have multiple slits, though. The structure is actually kind of complex internally, and should probably get an image of this, even though it's covered up partly, just to have one. All I did was rotate the image around a little, so I know it's sort of jumped a bit, but I wanted to rotate it so that it goes more or less corner to corner. Maybe I over-rotated it a little. So, you know, I could basically get the highest magnification. So I can get a little closer to it if it's this shape. A little bit more of the image is just diatom. And then I'm going to zoom in and try to get the focus really tight. It's sometimes easy to pick on something like the Raphy to do that. The Raphy here is a little obscured. And then I'll zoom back out and just grab a photo of this Afrocymbella for comparison, so we can see what type of Afrocymbella are present in this sample. This is not the one I was really hoping to find. This is not Muelleri. I think this is Bruni. Change the settings a little bit so it looks sharp, and then I'll take that picture. And then I'll hop back over and see what you guys are talking about. Hey, Pacific Plankton, how are you doing? It's nice to see you. I should give a little shout out to Pacific Plankton. Oops. If you really like microscope streaming, you should check out Pacific Plankton. And also, I don't know if Dell is still here, but you should check out Dell. Two of my good friends who stream. And hey, Headshot Specialist, how are you doing? Who hang out and usually hang out in my Discord as well. And Pacific Plankton streams usually on Monday and Thursday evenings, usually around midnight. And she always has great stuff that she collects from the San Francisco Bay, and Dell is also out in California, and he streams stuff from his microscope as well as playing games. Occasionally we do some game stuff on here. Hey, Headshot, thank you for the follow and also for the compliment. For Anakin, I do feel like the buzz makes it feel like you're in an actual scanning electron microscope room. Today I can't hear the buzz. I got waste blood in my ear, but it probably would cut down on the noise, or I could just put a little sound box over top of it of some type. It's just that, you know, I don't always get around to modifying things in the lab like that. We do look at dinoflagellates sometimes on here. We do look at spores, ribozoid. You mean like mushroom spores? We definitely look at those. Sometimes we'll get some plant pollen as well. Which type of chloroplasts are we talking about? The diatoms have a bunch of different types depending on which diatom it is for the chloroplasts. I'm not really focused on the biology very much. I'm actually a paleo guy. So hey Crispy, thanks for the follow. And also Kayla and Harry and Quiet Deviant and Canadian Corn Dog. Sorry if I missed those. I can't hear the alerts very well because of the music. But I think some of them have pyrenoid type chloroplasts. And I mostly just burn out all the chloroplasts. It's like step one for me is to get rid of all the organic matter. So yeah, it's not midnight there, but Eastern time it's midnight. And Little Chook goes to bed early, apparently, over there. We have looked at slime molds. My friend Anna sent us some slime molds. If you wanted to catch some of the things that we have streamed in the past, you can do that. If you look at the SEM Instagram page, where I colorize a lot of this stuff, you will be able to catch things like mushroom spores and slime molds and pollen, and other people use the scanning electron microscope. Look at nanofossils and that sort of thing as well. So let's see, 92. Uno momento. I need to save this file and rename it. And then I can move us around a little bit. We can try to find some other Afrocymbellas and other diatoms to look at. Normally the buzz from the SEM is also a little less noticeable because someone's in the channel, or someone's in the lab here with me hanging out. Mallory or Eleanor or Rihanna. Occasionally we get other visitors, but today it's just me, so the buzz is probably a little bit more noticeable from the vacuum pump. Huh. It's another really distinct Afrocymbella. You see how one end is a little bit skinnier and one end's a little bit fatter. It has this sort of dolphin shape to it. This is the head pole, this is the foot pole, and even though we can't see, there's some sort of schmutz on the valve face. The stigma would be here somewhere. These are the raphy ends in the middle. So not a great image, but that's definitely an Afrocymbella. The whole valve is, the whole frustule is there. For reference, there's other things present in the sample. These are Knitsia. It's also a really cool looking Knitsia right here. And I think that's an Ensynema. Not sure what this giant thing is off the top of my head. This is a endemic diatom, belongs in its own genus. This is Gomphinitzia. So I've mentioned this before, but diatomists like to sort of, when they have something that has characteristics of a different genus, they'll combine them. So this is like a Gomphinema-like shape, but the diatom's a Knitsia. So somebody's named this Gomphinitzia, sort of combining the two in a hybrid name. A portmanteau sort of type genus. And this is Gomphinitzia Ungurai, an endemic species for Lake Tanganyika. Very charismatic type. You can see it here. It always really distinct. I think it's monotypic. I don't know that there's other species of Gomphinitzia, but I could be wrong on that. Maybe I'm just familiar with Ungurai. Up here is a Salafara, an internal view of a Salafara. Knitsia. Not sure what that is actually, but this is a Salafara. Salafara have these characteristic little silica platforms on the ends of the valve. You can see it on both ends, even though there's a piece of a diatom covering the other one right here. And then their striae are uniseriate, which may not be obvious right here. And they have sort of a bow tie central area, thickened bit of silica in the middle. There are a lot of Salafara in Lake Tanganyika, and I suspect that many of them are not described. So my friend Itzi and I are probably going to have our work cut out for us on the Salafara species as well. I'm going to find us something to image, and then I'll jump back over to the chat, sort of see what's been going on over there. So this is what I've been looking for right here. This is Afrocymbella Ungurai. It's got a little bit of junk on it, including a Knitsia and a little Gomphinitzia or something in it. But you can see it's got a strongly dorsiventral shape. Oops. We got a subscription. Thank you, Pacific Plankton. We're not looking at any chloroplast headshot. All of the organic matter has been removed from these samples. So there won't be any of that. It's something I want to image but haven't yet. Yeah, there's lots of stuff. I don't have a confocal microscope. Pasta, whichever. Do I don't have a diatom actual command in here? Is it diatoms? Yeah, it's diatoms. Hey, Dirty Smith, how you doing? Can I zoom in more? Oh, I will. Trust me. I just want to get a nice overview first, and then we'll zoom in and look at the stigma, and probably down here at the foot pole a little bit. Actually, let me zoom in and get the focus tight. Can do that down here. As I mentioned, the internal expression of the stigma in Afrocymbella is a slit. These are the raphy ends you're seeing right here. And here's the internal expression of the stigma. And I'm just going to get that real tight so we can see everything clearly. And then I want to zoom out and get an overview shot. As before, I'm probably going to want to rotate it a little. I went the wrong way. One of the things that's really nice about the TestScan Vega 3, which is the type of scanning electron microscope that we're using, that's in my lab, is that it allows me to, one, have a carousel with 7 different samples on it at once, and 2, the controls for rotation and tilt are actually superb on this instrument. I can't remember what you guys can see. You can't see the little controller, but there's a controller that lets me change the tilt and the rotation. And it's got just a checkbox that says like keep in field of view, and that allows me to rotate no matter where I am on the carousel and keep the diatom in the field of view while you're rotating it. And one of the things I did with this when I first started using the scanning electron microscope is I would put a diatom on and then rotate it all the way around and take a picture every 20 degrees as I rotate it. And then I would change the tilt. It would also keep that diatom in the field of view when you tilt it. And then I would rotate it around every 20 degrees, and then I would tilt it again, and then rotate it around every 20 degrees, and tilt it again, and actually made a three-dimensional model. So here's an example of that three-dimensional model right here. So I made this entirely by using scanning electron microscope images, and then stitching them together in a program called Agisoft, in a process called Photogrammetry. Which is pretty cool. You can build a three-dimensional model using only pictures. It's basically what Google Earth does when it is giving you a three-dimensional view of mountains or anything, when you sort of drop yourself into a map on Google Earth. It's using the change in the structure as it takes pictures from satellite. So I think that focus is good, and I'm just going to tweak the brightness a little bit. And then I can come see what the chatter's about. I think that looks good. So we'll take that picture. And then I'll zoom in and do some close-ups. Yeah, you can always zoom in a little bit closer, although at some point when you start to zoom in, things get a little bit blurry. So once I get down into the sort of nanometer scale, where the things that we're looking like, the scale bar turns into nanometers rather than microns, the focus is a lot harder to do. A banana with weapons. It does very much look like a banana. Oh, you got a takeout emote from that Killathon. I wonder if I got an emote. Mama Bonbon is here. We should all wish Mama Bonbon a happy birthday. It was her birthday yesterday. And let's see, where are we? I'm going to try to catch up with you guys. Gang is all here. Well, not the whole gang. I'm missing my lab mates, but, you know. You want me to color it yellow? I can do that. Yeah. Confocal microscope uses lasers parallel to the view and creates fluorescence. It can be set to take progressive shots to build a layer-by-layer 3D model of an object, but it takes a long time and a series of layers instead of a complete object like an SEM. Yeah. I have an SEM, so I really don't feel like I need a confocal, but I'd kind of like to play with one. So this is a particularly clear image. You can see very distinctly the, move that out of the way, the apical pore field on the bottom of this Gomphinitzia. And as I mentioned, the internal expression of the stigma is this slit-shaped thing, and the striae in Afrocymbella fit internally inside these little costi. It's like rib-like structures right here. And then the raphes right here. One branch goes that way and one branch comes this way. And as I mentioned, there's some Knizia. I'm not sure what this thing is. Maybe another Knizia. This is an internal view. Ungurai. This diatom was named after a very famous diatomist who worked in Africa. The first serious study of diatoms was done by Mueller. It's very famous, especially for me. He worked in Lake Malawi, where I started working when I started working in Africa. And I think he was there in 1800s, late 1800s, early 1900s, looking at the diatoms of the East African Rift. So let's see, if we zoom in a little bit on the foot pole, we can see some of the internal structures a little bit better. So as I mentioned, there's an apical pore field. There's little tiny holes that are different than these holes that are up here, and you can see the external expression of them kind of wrapping around the outside of the skeleton right here on the apex. The raphe, which is this slit-like structure that has two terminations, one at the apex and one in the central nodule. This is one branch of that. And then at the end of the raphe is this little rolled tongue-like structure called a halictoglossa. And internally, as I mentioned, there's costae on Afrocymbella. And then you can see that the striae, which are hidden sort of inset in those costae structure, are slit-shaped or sort of lineolate structure, slightly oval. So that's kind of a neat image. You can also see the girdle bands on this diatom. You can sort of smashed in right here. The structure that's sort of right here is a girdle band, and it would help it connect to the other valve if the valves were together. On the outside of the diatom, here you can see the external expression of these holes right here, and they're in rows, which we call striae. It just means a stripe on the diatom in Latin. So all of the terminology for a typical Afrocymbella type diatom, and almost all of it can be seen on this image. I'm going to just go ahead and take that picture. That's a pretty one. It's a happy little diatom. That's my Bob Ross version. I don't think it's Johannes Mueller. I think it's actually Otto Mueller. Yeah, as Pasta La Pizza said. Yeah, easier to use confocal for something that's wet, probably. Nobody likes you, Knizia. Yeah. Well. Sometimes I can do my soothing voice. This diatom was holding up my camera so that it didn't look quite so... It's like my head was being cropped out of the image. The Bob Ross of diatoms. needed to change my soundtrack there. I know you guys can't hear it. I don't want to get DCMA'd or whatever, but in here, it's important. So, yeah, as I mentioned, this is Afrocymbella Ungurai. It's been elusive to us. We tried to prep some samples to look for Afrocymbella Ungurai, I don't know, maybe a month ago, 2 months ago, we did a stream looking at Afrocymbella. And I was really looking for Ungurai, but for whatever reason, the samples that we prepped, we couldn't find any in. And I've already found one. So, not the best. With respect to getting the whole valve in one field of view, but a nice clean look at the inside of the foot pole, half of the valve, and then just a little bit of junk in the middle. Here you can sort of see the clay. I'm just going to zoom out and then pick up again at the central area a little bit. Some of the things that the scanning electron microscope has as automatic controls, like focus, aren't very good because it doesn't know what exactly I want it to focus on. But it's pretty good at the auto brightness contrast. And as a photographer, that part of making that part sort of work out right saves me a lot of futzing with it. And maybe still not perfect all the time, but it gets it close enough that when I take it over into Lightroom to play with it later, it actually looks good enough. I can adjust it. I'm not wearing a mask. It's my beard mask. I just put a little filter right here over the mustache that hangs down. I'll be fine. So we got some follows while I was busy talking. Crispy, Allen, and Anir 7, 24/7. Thank you for the follows. Also, as I mentioned, we got a subscription from Pacific Plankton, and she's been subscribing for 4 months in a row. I've only been streaming for like 4 months in a row. Where somebody could potentially subscribe. So she got in before it was cool to subscribe. And she's got all my cool emotes as a result. You know, all the cool ones. All the cool ones. Hey, Mind of a Snail. How are you doing? We should give a shout out to Mind of a Snail. Bloop. Is the computer that I'm using super powerful? Nope. It's just a standard desktop model. It's got a pretty good graphics card in it. And there's nothing really that special about it. I get a lot of comment from computer nerds. They don't like the fact that it's running old version of Windows, but it's actually the version of Windows that runs this SEM the best. So we haven't updated it because TestScan prefers us to use this. So can it run Cyberpunk? I don't know. I don't have Cyberpunk. But I'm going to guess it probably isn't going to run it on the high end of the graphics side because the processor is just average. But anyway, you can see the slit-like expression of the stigma and these sort of antler-shaped ends on the proximal ends of the raphe branches. So this is the central nodule. We spent a lot of time on this particular guy. I don't really need to have a high-end shot of the head pull for it. I would like to get one that's nice and clean. Doesn't have junk on it though. So maybe if we zoom out a little, I'll be able to find another one. We'll just scoot around. There's plenty of other things that we could focus on. Spent basically an hour just looking through a little bit of each of these samples. That's one of the things that happens in the skinny electron microscope is you just kind of get sucked in looking at something and then lose track of time. These little casts right here I think are phytoliths, which are silica growing between the cells of plants, and they leave little casts of silica, and I think that's what we're looking at there. I have in my lab Dr. Chad Yost, who is a phytolith expert. He's doing a sort of postdoc with me this year, and we had him on to talk about phytoliths for an episode. We did little sort of phytolith based episode, which was fun. And I think he'll also be here next year, like the whole year, another academic year I mean, but we're still waiting to hear about that. But it's really great to have him around. We've done a bunch of work together. Earlier this year we published a book chapter together, talking about the use of diatoms in archaeological settings, sort of a microparticle analysis of diatoms used in archaeology. And I don't work in straight archaeology, but he has and does consulting sometimes for archaeologists. So it was good to have him involved in that conversation, even though he's not a diatomist. So I sort of figured I could handle the diatom side of the conversation, and he could handle the how do we use these things in archaeological settings and sort of speak that language a little bit better than me. And next semester he's teaching a class with me. Primarily it's him teaching it, looking at how to use microparticles, not just diatoms, but a whole wide range of different kinds of microfossil remains, including starch grains and pollen, diatoms, chrysophytes, and sort of calcite components in archaeological settings. So kind of excited about that class. I think we've got another one right here. Again, that's an Afrocymbella. Sometimes I guess the wrong way, but that time I didn't. Got a little bit more rotation. It's just a little fuzzy, so I'm going to fix that. And there's an example of, I mentioned sometimes the internal expression of the stigma or stigmoid has two slits, even though on the outside there's just one hole. So that's a pretty good example of that occurrence. You can see both of those slit-like structures where the stigma coming from the stigmoid. Just work on the focus a little bit more. That's a pretty one. So I just need to center it a bit. And then I can zoom in just a little bit better. Oh, too far. And then I will tweak this and let the instrument do its thing with brightness and contrast, and then I can come back and chat in the channel a little bit. So I might work on getting some text-to-speech, but I also feel like I kind of like having a sort of punctuated conversation where I can work on something and then kind of come back and see what people have been chatting about. Just structurally, it's kind of nice for me. I watch a lot of people play instruments on Twitch, singing and playing music, and that's the sort of approach that they use. And you just kind of get used to the rhythm of the person only being able to interact with you when they're not doing their thing. So, and then I think as we just end up waiting for a picture anyways, you know, like I said, I could just kind of like that structure. So I'm going to take a nice high-res shot of this one. I don't know that we'll find a better view on the inside of one of these. We haven't really seen an external view yet of Mülleri. But a higher resolution image also means that we have to wait a little bit longer on the photo. So this will be a 10-minute photo. So I just have to be patient, but it'll give me plenty of time to catch up with the channel. And we can just sort of chit-chat. Is it me? So Mind of a Snail said, is it me, or do diatoms look like they would be tasty chips? It would make great shapes to model a crunchy snack off of. Sea salt flavor. I think that would be fun as a chip. I have a really terrible story to tell about chips. The other day, after we were streaming, I went to, on the way home, I stopped at a grocery store, pick up some stuff for my wife, and everybody in the store had their masks on, except for this like couple that was walking around, and it was just a man and I think his wife and a kid. They were pushing around in the cart. None of them had their masks on. And as I was walking around the store the first time I saw it, I just didn't, like, I couldn't place what seemed wrong about it, because I wasn't thinking about the mask. I just have mine on and everybody has theirs on, so it wasn't really a concern. And then later on I realized, oh, the whole family isn't wearing masks. And because I kept interacting with them as I was going through the lanes, but I sort of kept my distance. And as I was getting ready to leave, I saw the lady had opened a bag of bugles and was eating them, like in the store, shoving them in her mouth, not just not wearing a mask, but was eating chips in the store. And I was just like, I can't take this. You know, they hadn't even paid for them. They're in store eating chips. Like she must have been really hungry. I mean, or Bugles just like hit a button for her. Anyway, there are some Pringle-shaped diatoms. To get back to the chip side of things. And my daughter Sylvia loves Pringles, so but just the salt and vinegar flavored type. Dangling or braided shrimp is back. Welcome back, braided shrimp. What are you up to today? I Watkins 2020 says, hey, what do you study? I am a diatomist who studies paleoecology, and also incidentally a taxonomist for diatoms, because pretty much anybody who does diatom paleoecology also kind of needs to be a taxonomist. There's a lot of diatom taxa, and as a result, you have to kind of get good at taxonomy as well, especially if you work in remote areas like I do. So I hope I answered that question satisfactorily for you, Watkins, but you can always ask more. Right now we're looking at the diatoms from Lake Tanganyika. Yeah, it's sort of chill. It gives me a time to think a little bit. Salt and pepper Pringles are surprisingly good. Yeah, I mean, salt and pepper chips are pretty good in and of their own. All right. Let's see. This this guy wants to get banned. That's fine. We can ban him. Hey, Pasta. Thanks for hanging out with us today. And, this is the Diatom Afrocymbella Ungurai. Hi, Miss Mary. I caught a little bit of your stream the other day, of course. You're working on Dragon. I should send a shout out to Miss Mary. She's an artist who knits. I think she was crocheting on Twitch, and was part of the Artist Back Alley artist stream along with me, so we participated in that. And let's see, who comes up with diatom names? It turns out I do. I've named diatoms in the past, and I'm also currently working on naming some diatoms in the present. When I say that I'm describing species of diatoms, what that means is I'm putting a name on them. So I'm turning them from something that's undescribed into something that has a name. How far did you get along in the dragon you were working on, Miss Mary? Headshot Specialist asks, how often do I stream? So I stream on Twitch, usually on Wednesdays and Saturdays from 1 to 3 on the Scanning Electron Microscope. And I will occasionally also stream from home on a light microscope. And sometimes my daughter will also join me on streams, and look in a light microscope, or she will at least occasionally will also play some Minecraft or something like that on a stream, or rather she'll play and I'll just add funny commentary. I think recently she's been going back to playing Slime Ranchers because they have a Christmas update, and she wants to find a Twinkle slime or something. So those night streams, the ones that I do from the light microscope, or if we do Minecraft or Slime Ranchers or whatever, those usually are in the evenings when I'm home from work. Right now, I'm not really at work when I work. I'm just working from home for the most part. So, hey, Devil and Mrs. J, how are you doing? It's nice to see you here as well. So I give you a little shout out. Oops, at Devil. There you go. You should check out Devil and Mrs. J. You should also check out Miss Mary. I should point out, for both of those people, those are mature channels. So here we try to keep things on a family and science focus, but so I try to make sure that I keep my potty mouth to a minimum, but those are mature channels. So if you're going to check them out, make sure that you're qualified to do so. But I think they both have great content for makers on Twitch. And let's see, what I missed something there a second ago. Oh yeah, Headshot Specialist says they are watching us from Algeria and they love our work already. Well, thank you. I really like, as I mentioned in the sort of notes on the About Me section, I like making things that are very small into something that people can see. I really like the idea of this sort of invisible world that's around us. And things that we either cannot see because they're too small, or they're visible to us, but we just don't know what it is that we're looking at, or can't see it very clearly. And I really just love taking scientific instruments and bringing that to light, or to making it accessible to people. It's sort of the center of my sort of public outreach that I do, but also, as I mentioned, I do photography, and it's a sort of focus of my photography as well. So I like to focus on either macro or things that are very far away also. Like telescope work is also kind of cool. It's a cool little diatom. Very skinny Gomphinitzia. Could potentially be an Afrocymbella, because it does have a slit-shaped internal expression of the stigma. It doesn't have much of a transapical asymmetry though, but that is a nice clean view of it. So I'm just going to go ahead and take a picture of that one as well, as long as we're here. Just a little bit of junk on it, but it's mostly clean. I think this species was described by Pat Kaselik, and it was before Afrocymbella was a thing. And I keep meaning to ask Pat if he thinks these could be Afrocymbellas instead of Gomphinitzas. So maybe having a nice clean view of it like this would be valuable in trying to assess that. Good. Let's see what we got. Hey, Sarah Dance Painter. Oh, we've got a whole bunch of people coming to visit today, which is great. My sort of fellow streamers. And you think I should name a diatom dangling? I'll think about it. Maybe I can give one a name that translates to dangling. Thanks, Emilio, and thanks for hanging out with us. You would not recommend your own stream? I would recommend it. Sarah Dane's Painter. I think she's done some really nice stuff. And actually, I was thinking the other day, Sarah, that you do all this sort of intricate drawing, that maybe I should give you some of my diatoms and then we can turn them into like a coloring book for adults. A sort of teamwork effort. You know, do you do the little detailing parts, and I can give you the, like, here's what diatom I want. I don't know. Maybe you wouldn't like doing that, but it seemed like something we could work on together. So, how do I receive my samples? Well, these samples came to me from my friend Itzi, and she used one of my colleagues to, who was visiting, to bring back the samples on a plane. And then when I went on sabbatical last spring, I collected the samples from my colleague. So normally people just mail them to me, though, or I go get them. And I do have some people who will mail me samples. I've got some samples from Miss Daisy D, for example, in the mail, and also Pacific Plankton sends me samples. It's a little more challenging when they're coming from someplace like Germany or Africa. Do the samples have to be sent to me still alive? No. I'm just going to kill them anyway. So, there's no point in sending me stuff that's living unless you want me to keep it living. But I'm going to put it in the scanning electron microscope and it's going to die. So, and then I'm going to zoom in on this one and get some close-up pictures of the central area. The central nodule. This looks good to me. So there's a lot of what I do on the SCM that kind of overlaps with my background in photography. And I mean, I'm mostly just using this really fancy instrument to take pictures, so there should be. But I think part of my ability to compose pictures and to modify them, colorize them, whatever else, probably stems a bit from my photography background. And so it's sort of nice to have that to rely on sometimes. Let's see. Hey, Andalore, how are you doing? Got a lot of friends that regularly drop by the channel that are here today. You make coloring pages anyway? Oh, that would be fun. You've collected some emeralds? Okay. For Minecraft, you mean? My parents are both doctors, and I have a big boy doctor books under their belts. Oh. Yeah, I like taking pictures though, and it's probably another one of my, like, that's how I relax basically, is taking photos. So how have I been? I've been good. Recently things are okay, and classes are all over, so I started drawing again. I've got some new Diatom artwork that I'm working on. I think most of the stuff that I have up on the Redbubble site, I can put that in here, is what's going to be on there for Christmas. And then I'm going to work a little bit on the ones that I have coming up, which are some benthic species, and a little bit different drawing approach to them. So, but I think that the one I have is starting to look good, and then I have a couple more planned, and then we'll see where that goes. But probably won't have anything up there before Christmas. So if you're gonna buy something from Christmas, what's up there is what's up there. But like the subs, anything that I sell through that website or through Twitch, the money goes, I pay taxes and the money goes into my bank account, but then I use it to pay for student research, or I contribute it back into the lab here. So big nerd vibes. You'll be ordering in January? Oh, that's nice. Thanks for your support, Mama Bon Bon. The central part looks interesting, but you have no idea what's going on there. Well, I'll talk a little bit about it instead of just blabbing here. So hang on, this is a central area. So what we're looking at, again, I suspect this could be Afrocymbella, because it has the characteristics of Afrocymbella, which is the stigma has a slit-shaped internal expression. It's on the dorsal side of the diatom, although it's hard to tell dorsiventral. And then these are the raphe ends. So these are what's called the proximal ends, or the close ends, close to the center of the diatom of each of the raphe branches. And then in some diatoms, there's sort of like a tube that connects these two branches together that hides inside the silica here. I don't know if that's the case for these. This looks like maybe it's solid silica. And then these are the striae, areolae, the normal structures that we would see on these kinds of diatoms. So again, I suspect it could be something that needs to be moved to Afrocymbella. If we look up here on the skinny end, this would be the foot pole, and I can slow the beam down a little bit. What we should see, it should have an apical pore field down here. We can't really see because this thing has a septa that covers over the apical pore field. But here's the halictic glossa. This is the terminal end of the raphe branch. And then this is the head pole, I think. Although, I guess I should make sure. Sometimes diatoms have weird foot poles that are a little bit wider than their head poles. I don't think that's the case with this one, but I guess I better check. Oh, that might be the foot pole, actually. No, I think it's a head pole. I don't see any structures in here either. So, but again, it has a septa that covers over the apex. It's a good view of that septa though, so I'm just going to take a quick shot of that while we're here. Oh, get a cheer from Devil and Mrs. J. Thank you. Student research Rolls Royce. I think I've made about $60 on Redbubble merchandise so far this year for student research, and I think I've made about maybe $300 total on Twitch. So it's not like it's really money that's gonna sustain me. But it is money that could very easily come back in and help pay for some student research and also pay for some of the supplies in the lab that we use during the stream. So Sarah Dance Painter says, so let's say you're a young Sarah Dance Painter unsure what to study, art or biology, or both. It seems like this would be a nice compromise. I mean, that's basically where I am. I have sort of like an artsy and science background. And you don't need to be young to study science. You can come and start studying science whenever you like. So it's never too late to start. LD 1872 says hi. Hi, how you doing? Right now we're looking at some diatoms from East Africa. Been watching ads to earn bits. Oh, I got it. That's where the cheer came from. Yeah, I thought about doing that. I don't know, do you have to interact with it much, or can I just let it run and turn the sound off? You need the gold for the SEM. Yeah, well, we don't have to replace the Sputter Coder very often, so... Yeah, I think you can click on the thing that says, like, get bits. I think it'll let you watch ads and get bits. It's a cool diatom, though. I'm still not convinced this isn't part of the apical pore field right here. It'd be kind of backwards if that were the case, but it wouldn't be the first time. I could also tilt it if I really cared. But I think we spent enough time on this guy. We'll move on. There's another one of these little sort of long, skinny... There's an Afrocymbella that has this shape. A Shiranai? I think it's Afrocymbella Shiranai or something like that. And it is in Tanganyika, so it's possible that that's what that is. Oh, here's another one of these. Cool looking Gomphinimas. It's an external view. I haven't seen a lot of external views today. This is Stigma. Sort of 3 Stigma. Again, I'm not totally convinced this isn't something else, but probably belongs to Gomphiniba. I think this is another one of those that Pat Gaseluk described. It's not a great view of it. It's got a lot of schmutz on it, so I'm going to skip it. See what else we can find. There's an internal view of one. Same thing we were just looking at. I think it's Killamai? Gomphiniba Killamai? Again, it's very close to Afrocymbella. Almost exactly the same internal structure. Just doesn't have the sort of bend to it. There's a septa at the top. Foot poles covered with junk. But the central area on these is very, very similar to Afrocymbella. The auto brightness is having a hard time figuring out what to do with this one. There we go. Alright, sorry for missing a bit here. I'm going to come back to it. Let's see. HT Local says, hi, I'm a noob. How are these samples prepared? I think they have to be sputtered. Yes, these were sputter coated with gold in a Denton Desk 5 sputter coder. That's over there. Really, I did that about maybe a half hour before I started streaming for these samples. I prepped them last night by yesterday by drying them onto little metal stubs. They look something like this. This part, the cylinder at the top, I dried the sample onto, so you're seeing right there is actually what's on a stub. And then I use a little bit of carbon tape and attach it to these Tescan pins that fit into our carousel, where they go into the SEM. This little pin basically holds it in place. And there's a set screw in the carousel that basically keeps it from moving. and rotating or anything else while it's in the SEM. So I think you can see that those are gold colored, but maybe it's not completely clear in the camera. If I get it a little closer, you can see the sort of gold color. Probably. It's having a hard time focusing on it. But it's got a slightly golden color to it from the deposition of gold onto the samples when they're mounted. Can I tilt the stage? Yeah, I can. I try not to do that when I have a whole bunch of samples in there, because it can calculate whether or not my sample's going to hit it if it's in the middle of this. But if I tilt it far enough, actually the edges of the carousel could hit the cone and it destroys my instrument. So you have to be super careful about it. Usually I have to lower the stage and then tilt it and then bring it back up. And it's time consuming. So I try not to tilt it unless I'm really trying to do something special with it. Hey, John Smith. How you doing? Spaceberry, hello. Glad everybody's doing well. What's a diatom? Diatoms can... Right there. Single-celled algae. And was once living. Now it's dead. This is... Gomphinitzia Ungurai, central nodule. That we're looking at right now. I'm going to zoom out a bit and see what else we can find on the sample. So if I just zoom out a little farther, right to here, the entire field of view is what's in 1 millimeter of space. So this is 1 square millimeter, essentially. And these diatoms, for some idea of size, so you can get some sense of the size. I'm going to look at this thing right here. I'm going to zoom in on it. This is, again, Gomphinitzia Ungurai, I think. So we can just zoom in and actually just keep zooming in. This one's a little broken. There we go. So that's pretty decent focus. It's got like a bits and pieces of something here. Super weird. I don't know if that's part of the girdle band or what it is, but this is the foot pole, this is the head pole of this species. It's actually quite long. And if I zoom in down here, you can see the apical pore field, which is this part right here. And Gomphinitzia live, when they are alive, attached. And they do that by squeezing some polymers out through these little holes, and EPS then basically, or polysaccharides, allow them to create a little tube that they attach with. It's on this end. So they can crawl around, and they can also basically put that tube down, structure, and then they can live attached lifestyles. They're benthic diatoms. They spend most of their lives attached. There's another Afrocymbella, a different species of Afrocymbella. This is one I think we're going to name. I didn't want to tell you what the name might be, but I don't think this one has a name yet. Some sort of technical issues about giving people names of things before they have names. So I'm not going to mention that. Probably a new species. but it belongs to the genus Afrocymbella. One of my sort of normal co-hosts here in the lab is student Mallory, and Mallory and I are working on describing these Afrocymbella. We've really been sort of at it for a while now. I've got the paper mostly written, I just haven't submitted it yet, and part of the reason was I was trying to get a few more good SEM images and line up some nice light microscope images, and really hoping to work on that sometime this week and try to get it off of my plate. Most people take a break when they take a break, and I usually use that to get some research done. So it's nice to not have any classes, and a little weird sometimes for me to like not have anything specifically to work on right away. So we saw this Afrocymbella already. We've gone all the way around the outside edge. And I think maybe what I want to do is jump over to a different stub. Unless I can find another Muelleri, just scanning around here really quickly. I think maybe that big one that we were looking at might not be Muelleri even. Maybe it's Gracilis or Pergracilis. I don't know. Not completely convinced it's in the right size class. I'll have to look closely at it. Let's jump over to 6, which is the same sample but a different stub. The concentration's a little bit different, but it should have the same species, basically. Maybe I'll zoom in a bit. Some Afrocymbella. There's a lot of diatoms on this slide. Some of them are actually in their life positions. There's some that are in a colony together. I'm going to zoom in on this guy. It looks kind of interesting. Is this a girdle view? It's a girdle view. So diatoms, when you can see the raphe and the valve face, we usually refer to that as the valve view. So this diatom, for example, is in valve view. If it's laying on its side, like this one, you can see 2 of the valves, or the whole frustule. That's usually referred to as the girdle view. It's basically laying on its side. Again, that looks like it may be an Afrocymbella. I think that's Afrocymbella Tanganyika. All the same characteristics are present. It's just slightly asymmetric. This is an Ensynema. You can tell Ensynema from Afrocymbella. They have a similar shape, and also the raphe curls downward, but they don't have a stigma, typically, and they don't have apical pore fields, so there's no like distinct foot pole, head pole, and that's because Ensynema usually live in sort of like a sheath colony together, kind of interesting tubes that they live in in a colony together, and it's kind of cool lifestyle. But Tanganyika again. All these little guys that look like needles are Nitzia, and these ones are, I think it's a Gomphinitzia. They look like a bowling pin. You can kind of get a sense in the range of sizes. Some of these things are actually really large relative to their peers. Still would be very small in real life, but it's another Afrocymbella. Now known as epithemia, but used to be called Rhopalodia. Just kind of aimlessly drifting around on this sample looking for Afrocymbella species. It's mostly Nitzia. And Gomphinitzia, and these Rhopalodia-like organisms that we now call epithemia. Again, these are samples from Lake Tanganyika, which is in Africa. Sort of straddles several different countries in Africa, and is a really important resource. We've published several papers on Lake Tanganyika, the paleoecology, as well as some working on some taxonomy papers from it as well. There's an Afrocymbella up there. I went the wrong direction to get it in field of view, but I'm just going to keep going in the way I was because it's not the one I'm looking for. Normally on the weekends and also during the weekdays when we're streaming from the scanning electron microscope, I will stream for about 2 hours. So we're kind of encroaching on the 2-hour limit. It's a self-imposed limit. So I can always stream a little bit longer. I started a little early today, but when it's just me in the lab, it's a little bit more, I do what I want. And while we sometimes focus on looking at other cool things, today my plan was to try to just focus on getting some things I really need to get imaged. And I feel like I've gotten some of that done. So that's nice. And it's nice to be able to share actual research with people. So I'm glad everybody was able to hang out with us today. And we'll probably go on for a little bit longer here as I'm sort of exploring these samples. I might try jumping over also to the larger stubs from a slightly different sample, depending on what I find here. So it's always a bit of a hunt. when you're on the SEM, and what you're looking for isn't gigantic. So if we were to zoom way out, so at maximum range right here, and our diatom was large, we'd be able to pick it out very easily. But when the diatoms are sort of moderately small, sort of in the 20 to 50 range, it's a little more challenging to stay zoomed out like this and actually see anything. I want to zoom in on this guy right here, because it's kind of interesting. I mentioned that we don't just see diatoms. When we process these, we sometimes will also see other siliceous components. This is a sponge spicule. A really cool looking sponge spicule, kind of knobby. Sponges will put silica inside, sort of as a structural element, also to keep things from eating them, nibbling on them. And these ones are really, looks like a breadstick, right? Or maybe it's just, I haven't had lunch yet, but kind of a cool looking sponge spicule. Sometimes they've got all kinds of really sharp, sort of jaggedy components coming off of them as well. It's this one that we saw before. This is just a different specimen of that same species. Again, it has a similar structure, so potentially an Afrocymbella. Gonna just rotate it around. And take a picture of it while we're here. We have it. Too close. Sorry, it's jumping around a little bit. It's because I'm trying to get the angle right first, and now I'm trying to get the focus perfect. I feel like I've managed that. Got a really nice view of it. And I'm just going to work on the composition a little. There we go. Looks good. Speed's good. Set the brightness, and then I'll take a picture. And then I can hop back over to chat and see what everybody's been talking about, if anything. You can really see it sort of scanning now. The scanning component of the scanning electron microscope is building the picture as it basically rolls across the specimen. Go. Happy little diatom. Okay. Oh, I missed a bunch. Sorry about that. I'll come back. Do diatoms make people sick? No. So I'll answer that right here. Sorry, it's actually missed quite a bit. Spaceberry. Where do diatoms go when they die? Hopefully into my scanning electron microscope. I should point out if I missed anything, and I often do, you can always ask questions on our Discord. So there's a link to the Discord as well. Let's see. Everything in here is dead. And we are seeing some things that are inside of the organism's skeleton. So the scanning electron microscope is allowing us to see the cell wall of the algae, essentially. And they are normally transparent, yes. So the wavelength electron microscopes use a electron beam, and the electron itself has a wavelength of something like half of a nanometer. So very small wavelength for electrons, and that's why we can see things using them. Can I render a good image of something? I'm working on it. How much electricity does the electron microscope consume? It's actually, most of the time it's in standby mode. So unless it's running, it's not actually using much electricity. And when it's running, I think it's probably comparable to a microwave or something like that. It's not really using a ton of electricity. Let's see. Hopefully I'm answering questions. Do diatoms make people sick? Only a few, but none in the freshwater realm. Only in marine settings, there's a few. What even are diatoms? They're a type of golden brown algae. That question's been answered. Yeah, the electrons function like light in the scanning electron microscope, and the lenses in an electron microscope are actually magnets. Can I poke one of them with a really thin needle? Well, these things are just the skeletons, but they do have scanning electron microscopes that have micro manipulators in them that allow you to poke things and move things around and break things. Mine doesn't have that. You probably wouldn't. A needle probably wouldn't help. These are really, really tiny, and it's inside of a vacuum chamber. Yeah. Are we looking for a diatom in particular? Yes, I'm looking for Afrocymbella, which I think this one belongs to in that genus. But I'm also kind of working on some other Afrocymbella, characterizing ones that are unknown, that are in these samples. So I have a soothing voice to knit to. Well, I don't know that I've ever been told that specifically, but I'll work on talking as much as I can to keep you knitting. Afrocymbella are either in this diamond shape, or they are a little bit more like a banana shape, basically. Yeah. Okay, so I'm trying to catch up still. I think I did all those things that people are asking. Diatom's attack sounds like a heavy metal band. I like to think of it more like a 50s monster movie, but originally the name was going to be for a band. I was going to call my band Diatoms Attack Formation. And then more of a punk band probably than a metal band, though. Yeah, they're tiny algae, not plants. They don't have the structure of a plant. They don't have roots, and you know, plants are multicellular. How often do I stream? From the Scanning Electron Microscope, I stream every Wednesday and Saturday, if I can help it, from 1 to 3. So it's already 3. Looks like a cactus. Getting hungry looking at the diatoms. That happens to me. Yeah. Oy, there was so much talking that I missed. How have I not found your channel sooner? Oh, thanks for the follow, Tribeca, and also M. David, M. Lady, and John Pott. I don't know why you haven't found it sooner. Maybe maybe you didn't type in Diatoms. I don't know. Also, thanks for the follow, Spaceberry. I can see the Discord chat channel thing that I typed, so, and some people are helping out with the other commands. Tribeca asks, what type of SEM do I have? This is, there's a command for that, but it puts a giant block of text in. This is a Tescan Vega 3 tungsten SEM. I can show you a picture of it. Or rather, I can switch over to my phone for a little bit and show you, do a little tour. Let's see. Oh, somebody hit the SEM button already. Okay. This SEM doesn't cost $500,000. It only costs about $160,000. And okay, I'll work on the tour. Hang on, I'll set that up. It's a little bit of work on the on my end. Let me just take a really quick finish this, and then I'm going to zoom in on the central area a little, or one of the ends. Symbella SP full, and let it do its thing for a minute while I switch over the scene to my phone, so you can get a little tour of my SEM lab. I have 2 labs, and I haven't streamed from my light microscope lab, which is where my undergrads have their offices, and we have a series of microscopes in there, light microscopes, but maybe I'll do that for one of my streams. I keep saying that, and then I never get around to actually doing it. But I do have one of my lab microscopes at home, so we sometimes will, I'll sometimes stream from home. I'm just going to start that, so you guys have something to entertain you while I work with the OBS to switch over to my phone for a second, and then I'll do a little quick tour of the lab. I need to droid cam on. And oops, that's the wrong app. I'll start the droid cam. Perfect. And I'm going to just leave it on the room microphone because I'll probably be mostly close to the microphone. I'll just try to talk a little bit louder. So let's switch over to the droid cam. While that's rendering. Here you go. And hopefully you can still hear me. There's my glasses. Here we are set up. This is the computer setup with cameras right there that you've been watching me from. Oops. This is the actual scanning electron microscope itself. So Tescan Vega 3, and you can see it's about the size of, it is basically the entire desk. And there are essentially two computers. One runs the actual SEM, which is the software that we're using. Sorry, you're on the OBS software, so you're watching stuff that you don't necessarily need to watch. But if we come around here, this is the elemental analyzer and the EDAX elemental analyzer. And that's the actual SEM right there that you can see. And up here at the top is the electron gun that sort of fires down through this chamber where all the magnets are. And then the actual chamber where the sample is down here, and that's the secondary detector. And over here is the infrared camera that looks into the SEM chamber. And this is the noisy pump that you hear in the background all the time. It's basically just pumping the sound that you're hearing is just keeping the chamber at a vacuum that it needs to be. And then there's some samples over here, but I'm really trying to just showcase the Sputter Coder, which is this instrument right here. And the Sputter Coder is how we put the gold plating on. So you can see there's sort of a bell chamber at the top for the Sputter Coder, which is used to, you put the samples in there and pump down a vacuum and then make it turn into plasma, covers them with gold. Over here, just some samples and a little stereo microscope that we use for prep sometimes. Over here also some material that we're using to prep. That's basically the whole SEM lab. Hopefully everybody gets a pretty good sense of what's going on with that. And I'll jump back to this thing. Turn off the droid cam. I would take you for a tour of the other lab as well, but the internet connection between here and there is not that great for my phone. So, sorry, it's hard for me to speak up. The microphone was here. I could use the one on my phone, but then it doesn't sound very good. So, mostly we're just looking at the different components of the SEM, right? So, yeah, it's basically the size of a giant desk. So, let's see. Hopefully everybody enjoyed that short little tour that we did. Let's see. I worked with an awesome SEM back in a previous job, and I loved it so much. It was a Zeiss multi-SEM. Oh, well, that's cool. I've never used a Zeiss SEM. I've used a field emission. Oh, thank you for the follow, Lima Fox, and also Gosu Potential. And I've used a field emissions SEM before, and I grew up, back in the day, kind of cut my teeth on a Joel SEM, which would produce pictures on Polaroid film that we would have to sort of rub in our hands after we take it out of the container, and then heat up the chemicals, let them sit for a couple of minutes, and then open it up to figure out whether or not the picture was awful or not. So sometimes that would happen, and so I spent for my PhD, I used that type of a SEM, and then eventually the school got a nice field emission that I used during my postdoc, and a little, and then this one is my own, which is nice. I mean, the university owns it, I don't, but it's under my control. So, let's see. What's the thing we're looking at? Oh, this is an Afrocymbella, I believe. It's the central area of an Afrocymbella. and I don't know which species it is. I think it's Acheroni or something like that. Or potentially it's one that's been misplaced as a Gomphinitzia. So I need to look carefully at the size and the striae density and make sure what I'm looking at is what I think it is, and that it's been described before I can answer that specifically. But we're looking at a diatom, so you know, you probably don't care which species it is, but I think it's Afrocymbella, and it's got a really weird structure to it. It sort of looks like a pin. We've been looking at mostly Afrocymbella and Gomphinitzia today. There's a bunch of other types of diatoms in these materials, of course, but I'm focused on those because I'm trying to get some actual research done today. A lot of times I might just screw around and show people things. Here's another one of these. Same species up here. This is the same species we were just looking at. Doesn't have as much junk in the middle. You can see the same structure internally. This slit-shaped thing is the internal expression of the stigmoid, and these are the raphe ends right here, the proximal raphe ends in the central nodule of the diatom's cell wall. Or in diatoms, this is called a valve, and two valves together make up a frustule. This is, behind it, sitting right here, is a Starcirella africana. So this is from Lake Tanganyika. And then there's a bunch of Knitsia here. I'm not even going to try to tell you what kind of Knitsia they are. Although I do have an SEM, I don't have the species names in front of me for many of those, and I'm just not familiar enough with them to spout them out like I am other things. Here's a Placanese. This is a really pretty Placanese. Look at the structure on the areolae. Really gorgeous structure to the areolae. I think these types of pore coverings are called tecta. So that's a characteristic of the Placanese genus. Just absolutely stunning pore coverings, and I'm going to super well preserved, because these are modern samples that were collected from living organisms, but I really just love that pattern. Look at it. I'm glad we focused in on this one. So I can tweak this just a little bit, and I'm going to, because I want that to be perfect, and it's just a little less than perfect at the moment. So one thing I can do is decrease the beam size. I just did that. And then I'm going to zoom in even a little bit farther, because this is nuts. And try to get some of these just as cleanly as I can get them for you. So that's a nice, pretty shot of that component, but the stigmation could probably still just be a little bit better. I'm going to play with that right now. See if I can get it perfect. It's pretty good. I mean, we're looking at this diatom right now at that scale bar at the bottom says 200 nanometers. So our magnification currently is 235,000 times. just to give you some sort of sense of the quality of this image and the resolution of things that we can pick it up at. 237,000 times. A normal light microscope has a limit of 1,000 times magnification. So like 230,000 magnifying times higher than, than that. So that is pretty crazy. And we're still at the sub-nanometer or sub-micron scale bar on here, and our image still looks pretty good. But I'm going to zoom out so that you can get a sort of a full view. Even though I really like this sort of zoomed-in view, I sort of feel like if we just go out a little bit, we can keep all of that resolution and still tell we're looking at a diatom. And then I'm going to slow this thing down so it actually draws that image for you really cleanly. What a gorgeous diatom. So this is a Plaque. Tecula? Can't remember what those types of pore coverings are called, but they're characteristic for the Plaque genus. They're like a little covering that goes over the opening, and I tweaked the brightness and contrast, so now we're looking at this thing in really high contrast, and I'm super excited about this. This is a great view, and something I'll probably colorize and post on the Instagram a little bit later, because that's really pretty. So I'm going to do one like this where we're up super close and we're looking at those structures. And it's going to be a 10-minute photo. This is just because we're looking at it at such high resolution. And I've got the beam intensity down to 5, which is basically half the size it normally is. So let's see. And then I'm going to try to catch up with chat a little bit. Hopefully you guys are enjoying this this image as much as me. Let's see. Like punch cards, yeah. Slice machine was pretty nice. It used 61 concurrent beams, so you could collect the imagery super fast. Oh, that sounds fancy. That sounds like a super fancy lab. Hey, OpenSet, how you doing? We should get a shout out to OpenSet. If you like watching microscope streamers, I have a bunch of friends on here who are microscope streamers, and OpenSet is one of them. So there's OpenSet in particular. He does light microscope streaming and simultaneously plays synthesizers and sometimes reads poetry and whatever else. Super cool sort of stream, and educational at the same time, very entertaining. So your question was, how far could you zoom in? I hope I answered that. I went 237,000 times magnification. We still could get a pretty decent picture. So that's a crazy amount of magnification. Yeah, the text-to-speech is funny. And I've got a whole window here with the text-to-speech. It looks like a wall of text, but it's probably screwing everything up. It does its best. Yeah, I'm zooming in on them. They look crazy, don't they? So this is what I love about the scanning electron microscope, is just the detail that you can get at this sort of sub-micron scale. So they're little coverings that close over the pores. Some have, it looks like some of the pores have 4 and some have 5 and some have 6. It's basically the size of the pore that determines how many of those it needs to be on there in order for it to cover, like a little 4-leaf clover or a window. Yeah. So the Windows logo, that's pretty good. Devil and Mrs. J. Yeah, and I have a bunch of images on Instagram that I colorize, and I'll put this on the Discord as well. The level of detail that you can get out of the scanning electron microscope is really amazing, and I hope you guys enjoy it as much as I do. Really like being able to share these sorts of things with people. And normal view. Do I have a Twitter? I do, and the Twitter handle is exactly the same as my actual... Oh, we're being raided with a party of 187 people from Strange Parts. Holy cow, Strange Parts, you picked a good time to show up. Right now we're looking at a diatom on the scanning electron microscope, and I do a lot of work on the scanning electron microscope. We stream into the from the SEM to Twitch twice a week, on Wednesdays from 1 to 3 and Saturdays from 1 to 3. And right now we are looking at a Plaque. I meant to be looking at Afrocymbella, but I stopped to look at this because it was just absolutely gorgeous diatom. This is a Plaque. They have these really intricate structures on their striae in the areolae that are little pore coverings that are right here. They look like a Windows logo or a four-leaf clover. I backed this out to about 39,000 times magnification, but at one point we were zoomed in up on this section of them, looking at one of these at 237,000 times magnification. So, and then I stopped to take this picture, but the scanning electron microscope is very slowly scanning across the surface of this organism, the skeleton of a diatom, and drawing electron by electron, basically, what the electron beam is interacting with. And so the little tiny cracks that you're seeing, all of these things are happening basically at the sub-micron scale. And a really exciting high-density view that I've put together for this one. So hopefully you're having a good time sort of checking it out. Let's see. You had a microscope when you were a kid, you could do like 500 times. Well, most microscopes are somewhere in the range of 200 times to 1,000 times. Let's see. Yeah, and OpenSet gave a link to my Instagram up there just recently. So if you're interested in seeing more images from the SEM, this is my lab's Instagram. And I want to thank Strange Parts very much for a raid. I don't know how your stream was. You got a good number of people coming in with your raid, Strange Parts, so it must have been pretty exciting. Hopefully your group of people that have come in are interested in science, because that's what we're streaming right now. So this is diatoms are a type of golden brown algae. They make a siliceous skeleton, and they are dust-sized. So what you're looking at is essentially a dust-sized particle, and the intricate structure of the actual skeleton of that diatom. This is an internal view of the diatom Plaque, and this is from, all of my time zones are Eastern, sorry, so if I was giving out time zones from 1 to 3 Eastern in the US, because that's where we're located at Indiana State University. This is where my lab is, and I'm a professor at Indiana State. I study diatoms and I study paleoecology, and so we do a little bit of sort of science outreach here, where we just look at whatever cool things we find on the SEM, but today I'm doing a little bit of actual research trying to analyze some diatoms from Lake Tanganyika. So yeah. And if you're interested in, as I mentioned just briefly, if you're interested in microscope streamers, if you want to see other people or myself doing microscope streams, I've got a little squad of friends that are all microscope streamers. That's them right there. So A Tiny World usually looks around for water bears. I do a little bit of water bear hunting, and last night Dell was doing a little bit of water bear hunting, so Dell Maximum is another microscope streamer you should check out. Pacific Plankton is another microscope streamer. So she looks at plankton, living plankton from the San Francisco Bay, does really gorgeous views of living organisms, really spectacular, and she streams from Eastern time. That's usually midnight to 2 in the morning. on Mondays and Thursdays. Dell is usually on streaming and doing a little bit of gaming. His streams are typically on Monday, Wednesday, Friday, and sometime during the weekends as well. I think it's usually Sunday morning or Saturday morning. And then OpenSet, sort of free range OpenSet, is out there doing microscope streaming whenever he feels like it. So you can check him out. He plays music and looks at stuff on the microscope at the same time. I am the only person, I think, on Twitch who uses a scanning electron microscope regularly to showcase some of the science and cool little organisms that we find. I don't always do diatoms, as I mentioned. Sometimes we look at things like moss, lichen. We've looked at mushrooms. We've looked at slime molds. We've looked at all kinds of insects and beetles, bees, you name it. We'll put it on the scanning electron microscope and just sort of have some fun. I've got a regular friend here who's at the university with me, and she studies lizards, and I think sometime after Christmas we're going to have a lizard episode where she's got some dead lizards, and she's gonna dissect them a little and give me the parts, and then we're gonna put that on the stream. I don't want to cut up a lizard, but it's dead already, and we'll look at probably their claws and teeth, and I don't know, whatever else she's gonna give me to look at. Some of them are kind of partially mummified, but we'll definitely look at the skin, which will be super cool looking. So that's Sarah Losaurus, and she's a grad student here who's looking at lizards. So it should be fun. Probably terrifying too, because I don't like to cut up organisms if I can help it. But these are already dead, and she's super interested in seeing some of it in the scanning electron microscope, and she's a friend of our channel, so we definitely will we'll give it a run and see what happens. So very close pores, and I'm gonna so we've been watching this thing in super slow motion because I wanted to get a really high resolution shot. I can zoom out a little bit now that it's done taking that picture. You have to be sort of patient with the scanning electron microscope. And I will, let's see, change the beam intensity around, and change the speed setting and the brightness and contrast, and we should be able to get a nice picture of this little lemon-shaped diatom Placanese, and a whole field of view. But you can see that the diatom that we're looking at, the whole field of view that we can see right now from one side to the other, is 43 micrometers. So the 43 microns, that means there's 1,000 microns in a millimeter. So, we're down into basically fractions of millimeters in terms of the scale of what we're looking at. They're very, very small, dust-sized particles, but diatoms make up basically the bottom part of the food web. Everything that lives in water that needs to eat probably feasts on diatoms at least a little bit. So aquatic insects and zooplankton, and some other organisms that are just big enough for a diatom to put in their mouth, basically, and they will eat them. So I'm just going to go ahead and take that picture so I can hop back to chat. It's pretty chill stream today. Oftentimes I have my students here in the lab with me that can help me manage the chat at the same time. Right now I just got a bunch of cool mods that are taking care of stuff for me. So I want to say thanks to Pacific Plankton and Dell and OpenSet, who've been here really helping out today, and handling the raid for me. So and also I want to thanks to I had a whole bunch of people that have been visiting us today, and I'm really happy that Strange Parts has brought in some raiders. Hopefully you had something cool that you were also exploring today, and I'm going to follow you and I will check out what it is you do. I'm sorry, I don't know exactly what you would normally stream, Strange Parts. Telepresence robot. I don't even know what that is. So I've got a lot to learn. So Bluebird asks, are these organelles? Nope, all the organisms that we're looking at, all the diatom parts that we're looking at, it's just part of the cell wall. The cells are very intricate cell walls that they have. The organic material's all been removed from these. And yeah, that's fine. Thank you for bringing people in, Strange Parts. Salacious skeleton. It's a very salacious skeleton. Sometimes, you know, it's got a raphe and it's got areoli, so those are sexy bits. They sound salacious. No, but I meant salacious. So, right. Let's see. Good old Terre Haute. Yeah, that's where we are. Except for it's not spelled that way. What does the research provide at this microscopic level in real applications? So I study diatoms, and I'm mostly using the SEM for taxonomy purposes to try to identify them. And then we use that to reconstruct past environments. So my real application for them is paleoecology, using that to basically reconstruct past climate. And there's a whole bunch of my research. If you're interested in the About section, you can check out my publications on ResearchGate if you like, or you can drop by the Discord and we can talk a little bit about my actual research that I do. But mostly I do things like reconstruct past climates. These particular samples are going to be used to reconstruct past climates in East Africa, and also to, we're working on a really big project that's starting to get some funding to core the East African Rift Lake Tanganyika, to get a 10 million year record there, and to try to use it to reconstruct the evolution of some of the diatoms. So, you know, my interest in that is largely how evolution rates are influenced over time, and diatoms are one of the few organisms that can evolve at fast enough rates that we can actually see it over the span of thousands of years. So Spider AD guy is really cool. I'm sorry I haven't added him to the microscope streamers, and we also found another guy that OpenSet knows, Manor Labs, that's starting to stream as well. So we'll get them added to our list eventually here. I really lost the thread with everything coming through. Have I ever looked at a tardigrade under the electron microscope? BoxKid351 asks, and the answer is yes, we have. So if you go through our Instagram, you'll find some pictures of water bears that we definitely have put on the scanning electron microscope. No 100 FPS for a microscope. There is actually some ultra high speed scanning electron microscopes. This one's a little bit more, have some patience. You know, I don't have the $1 billion SEMs that can be used to scan all kinds of crazy things here. But you know, I still feel like it's a pretty neat view. So let's see. I'm still trying to keep up. The taxonomy is still not complete for living things. That's a crazy question, Timus. But I will tell you that probably about 80% of the species of diatoms still don't have names. So, or they have CF names, or names that basically say they look kind of like this thing, but they don't actually have a name. And there's actually a huge number of just basic organisms that we don't think have names, like insects. And there's no way that we're anywhere near having described the taxonomy for all living things. It's a good question, though. Spider Streamer streams usually in the mornings during the weekdays. So these are all fossil parts, Bluebird, yes. These are the skeletons of diatoms. They have an exoskeleton, a cell wall, basically, that's silicified. So, yeah. Oh, you've got a friend who does a confocal scope. That's cool. It would be cool to have more microscope streamers. So, yeah. So, let's see. I'm almost caught up. There's a lot of work that still needs to be done, yeah. So, and it's part of what we're doing. So we're looking at these really interesting environments. Looks like you can make some cool desktop backgrounds with this. In fact, I do colorize all of my SEM images, and I make them available for people in my Discord and also through Instagram. So if you are interested in using one of these as a a backdrop. I'm planning on setting up a separate thing this month for all of my subscribers so they can get high resolution versions of my SEM images, that a set of them that they could use for computer desktop or their phone. I'll probably just put a link to that in the Discord for my subscribers. So, but if you want low resolution versions of those, you can always just grab whatever we put up on Discord or on Instagram and go ahead and make it into your backdrop. I don't mind. So this is an overview. Sorry, and I'll get off this Plaque. I'm super excited about the image that we had right there. So, and I can zoom around a little bit to let you people who haven't been here in the stream watching what's going on. So here's a diatom. These are all diatoms that we're seeing, these little shapes that you have that are visible on here. I meant to end the stream about, I don't know, 15 minutes ago. Always happens when you're getting ready to wind up everything. There's a raid that happens with a lot of people with great questions, and at least I have the luxury of just continuing to use the SEM as long as I want, because it's my SEM. It's in my lab anyway. And if I feel like running a little long, no one can stop me. No one would want to stop me, really. I mean, come on. This is, I think, the diatom we've been looking for today. Still not convinced for sure that this isn't something else, because that one is very big. I think that's Stephindiscus let's see, Paragracillus? I think it's Paragracillus. This one is really huge diatom. It's got a little buddy Nitzia here hanging out with it. It's nice to be able to get it in the SEM. So it's not the diatom I really wanted, but it is the diatom that I got, and I will take it because it's cool looking. Paragracillus, I think is what the one this is. It's a really big diatom, and it's an Afrocymbella, which is what we were looking for. Earlier in the stream, I was really focused on trying to find Afrocymbella Ungurai, and I thought I had it, but then I think this one is too big for that. So what do I want to do? I want maybe 35. Just trying to rotate it so I'm going the wrong direction. 25, 15. I'm just trying to rotate it so I can get the whole thing in my field of view and get as close as I can to it. So, sorry. As a scientist, I have a bit of a OCD, where I feel like I have to have everything kind of looking perfect. And it's not a real disease in this case. I'm just fussy and like to have my images look cool. I mean, not saying OCD is not a real disease. I'm just saying I don't have a real disease, for clarity. I have a compulsion to make things look good. Okay, now I'm just going to zoom in and get the focus really good. Actually, it looks like it's fine. And then I'll zoom back out, compose the photo, and then we'll take a little 1 minute. Oops, moved us off the center. A little 1 minute, 3 minute photograph, something short and sweet. And then just have to be patient and let it, scan in. We need a banana for scale, and you sell me one. I've seen your taped bananas before, OpenSet, and also I've seen what they produce on your streams. And I don't want any of your bacteria-ridden, nasty bananas for my scale. Okay, it is very banana-shaped. Let's see. Oh, somebody's given out my Redbubble site information. Thank you. A bunch of people helping out with that. How do I colorize the images? So that's a good question, Bluebird. I take them into a program called Lightroom, and it's just like Photoshop, but it's made by Adobe, and it lets you change the, at first I have to turn them into JPEGs basically, and then I play with colorizing the different components based on the shadow, the midtone, and the highlights. And if I'm getting really crazy, sometimes I'll take it from there into actual Photoshop and tweak the colors a little bit more, or I might send it through multiple times and play with the color. And then I usually use some of the controls on Instagram as well to kind of change the color patterns to make different parts stand out, or to change the balance of the color a little bit. I know people ask me that question a lot, and I wouldn't mind streaming it, but I feel like it would be super boring because it's less exciting than you think it is. It just looks cool when I'm done, but in the process of making it's kind of boring on my side. It's a lot of me playing with sliders, but I feel like people ask that question a lot, so maybe sometime I'll stream it into my Discord channel or something like that. I do drawings as well, so somebody posted a Redbubble site, I think that was Sarah, and I will oftentimes draw the diatoms, some of the diatoms that are here, so I can turn them into artwork and put them on objects for sale on the Redbubble site. For those, I draw them largely in CorelDRAW. I sort of start with the SEM image and kind of trace over it, making shapes. And have I tried water crystals? You mean ice? Are you talking about ice? I don't have a cold stage, or I could try to put like snowflakes in there if I did, but I don't have a cold stage inside the SEM, so it would just melt. Probably by the time I got it in there, because the room temperature here is warm enough, despite me wearing my winter hat, it probably would melt. How do I get pure samples of diatoms? So that's a good question. I start off with samples that are sort of like a mix of things, and I put them into nitric acid, which gets rid of all the organic matter. And from there, what's left behind is sort of a residue, which we rinse everything out of the chemicals out of it to get it back down to neutral. And then I dry those onto an SEM stub or a cover slip if it's going in a light microscope. Per Gracilis, I think. And then they've got to be sputter coated in a sputter coder where they get gold plated. And then basically they can be mounted onto a stub to be put into the scanning electron microscope. So that's basically the process that got you from where we are to where we are, where we started to where we are, basically. So that's a good question, one that we kind of get regularly. And I would share that process with you, but again, that takes sometimes weeks for the stuff to digest. And if we speed it up using nitric acid like we did with these samples, it's like 2 hours of the sample sitting on a hot plate in nitric acid. So that part's super boring, and nobody wants to watch samples turn, yellowy brown on a hot plate for 2 hours. I think you'd rather watch some paint dry than that. And it all has to take place in a hood, so not super exciting to watch. But what is this thing? Oh, we've got a little piece of a copepod, I think, in my sample. It made it through the processing. Oh, that's kind of cool. I wasn't expecting to see copepods. There is a copepod that lives in Lake Tanganyika, so I'm guessing that's what that is. That's pretty funny. Exoskeleton somehow made it through the processing. Anyway, so that happens sometimes if they've got a lot of junk covering them. There's another Afrocymbella right here. That's one that I think we're going to name. And I thought I saw Mulleri hanging out up here. Not sure that that's Mulleri though. It is an Afrocymbella. A different species of Afrocymbella. You see how much smaller it is than the one we were just on. But I think that's actually the same as the one that was just over there. This one that we're working on describing right now. So, taxonomy undetermined for this one. I don't think that's Mulleri. Mulleri is a little bit more pointy, like a banana. Like the banana we had, but smaller. When I was going through these in the light microscope, I didn't see very many Mulleri in these samples. I saw them mostly on the other one. But the other one's got a bunch of clay on it, so I didn't rinse them. I need to go back through and like super clean rinse them and see if I can get some of the clays out. And maybe that's what we'll do for Wednesday's stream. So I also want to try to get a little bit of research done on Wednesday as well. So, and then we'll get back to fun stuff the following week or something, probably, with the lizard parts that Sarah's working on for us. All right. I think we've reached the point where I probably we should stop, and I can find somebody to raid. I want to thank all the people who've been hanging out with us today, and especially the raiders that came in, and also lots of friends that we've had that come by the channel regularly, that have been visiting with us today. So I'm excited to have everybody here and to be able to share a bunch of these really cool views that we have. And I'll work on improving some of these other things that people are asking, like potentially the text-to-speech components, so that I can keep up a little bit better with things in chat. Although it's still really hard to focus on this while I'm trying to focus on the chat. So, you know, I don't have high expectations for myself on that level. You just have to be patient. Science happens at sort of a slower rate sometimes than what people want. It's that same diatom right there. That we're working on describing. Yep. Ooh, that's a cool little diatom. Ooh, a tiny little guy. This is a Gomphinitzia. You can see it's super small though. And missing some of the interesting parts that are usually present on a Gomphinitzia, like a stigma, which would be on here. But I can't tell if it's just because it's got some clay. It looks like maybe it just has some clay over the middle part of the valve. Alright, anyway, so I think I'm going to pull the plug on today's stream. And as much as I love just looking around at diatoms all day, I do have things I need to get done at home. And I think we're building a gingerbread house today. We were going to do it yesterday, but the parts weren't all made. And I think the parts are all made. So if I don't get home, I won't be able to participate in the gingerbread house making. Which, you know, I'd like to be a part of. So, like I said, I want to thank everybody for hanging out today. I've had a ton of... It's Anitzia, sorry. Still can't keep up with the chat at all. There's so many people. I want to thank everybody for coming in. And I'm a professor. You can find out my information if you scroll down below. Or if you don't have a PC that you're viewing on, if you're viewing it on a phone, you can check out Diatom's Attack on Twitter. That's my Twitter home. Yeah, we've got a lot of people here. Tropical Geek, you're coming in right at the end. We had a huge raid from with a lot of people from strange parts, and we got a whole bunch of new followers. So I just want to say, for the people that I haven't already mentioned, Little Shrimpo, Bluebird, Chris, Houlihan, Darks 6000, Max Lee 2000, John Charbonneau, Gypsy Fan, 1969, Zint, Zitimus, Wis X, Clumpada. This is like a test for me to see how far I can keep going. C 2189, SG, Ratto, Pam, CCCC, Bitstorm, Pretzel Key, Matt Stace, Hootzer9, Cryogi. Look at all these followers. It's been amazing today. EC Nellis 35, Eingiki, and Izzy42. So that's just a ton of people, and that was just like after that raid that came in and visited with us. So and followers. So thank you for following. Really appreciate all the people that have been here hanging out, and I'm gonna catch everybody again on Wednesday. I just have one thing we need to do, which is like find somebody to raid. And for the people who came in a raid, you know, I'm gonna try to carry that forward to somebody else that we're friends with. So, and I think the person that we're going to attack with our Diatom army today is, let's go get Frecht Chemist. So she's just chatting. I don't know what that means with her. She's oftentimes in a lab tinkering around. Oh, she's on, looks like she's on some sort of lab space at home. So we'll go get Frecht Chemist. And, oh, she's building a 3D printer. Cool. Okay. So we're going to do that. And we love Frecht Chemist. She's one of our favorite people to hang out with. And hopefully you guys will enjoy that. So we'll send people that way. If you have questions and I wasn't able to answer them, please check out our Discord, where you can always ask questions and catch up with me. It's a great way to hang out and check in on our community. I post pictures from the stream there as well. Instagram photos usually go up into channel there as well, and you can catch a little bit of our friends in our community there. So thank you everybody for hanging out with me today. And you know, I don't have my normal lab assistants with me that would help with the chat. They probably would be overwhelmed with the number of people we have here anyway. But I really want to say thanks to everybody for coming in. I really appreciate it. And like I said, we'll catch you on Wednesday, Eastern Time, 1 to 3. And I might do some night streaming from my light microscope as well, sometime this weekend or into the early part of next week. So, all right, I'm going to send everybody on the raid. I want to say thanks once again, and I'm going to hit this button, and then we'll see you next time. All right, bye.